Now we come back to we come to sample problem 8.1, and now we have a 100. We have a block. We have a block, and the weight of the block is 300 Newton. This the block is the weight of the block is 300 newtons, and we have a force of 100 Newton pushing up. And incline means incline means this one. And the coefficients between the block and the plane are mu s equal to 0.25 and mu k is equal to 0.2. Determine whether the block is in the equilibrium and find the value of friction force. Now, so we need to determine two things. The first thing is whether the block is equilibrium, and the second thing is the value of friction force. This is 1 and this is 2. So, and in equilibrium means, what is equilibrium? Equilibrium means, what is equilibrium means in equation form. When we write something is in equilibrium, what do we mean? It means summation f equal to 0. Okay? Actually, it means in friction, it means no motion. If it is not in equilibrium, summation f is not equal to 0, it means motion, right? Or f equals to ma. It's okay. Now we come to so I think I've explained the problem, and then we go ahead. And first of all, we draw the free body diagram. We draw the free body diagram. Now, and so we have 100 Newton going up. And what else do we know? What else do we know? We know the weight of the block is 300 newtons. It means 300 newtons is going which way? Down. So before we do the mathematics, we first draw the free body diagram. So we have 100 Newton pushing up, and then 300 Newton is going down. What else do we know? I think that's all we know, and but we know we have a reaction force here, which is and I'll put it I'll mark it as N here. This is the reaction force from the plane to the block. And the last thing is we have a force because we have it. Because this plane on this plane, we are not saying it is smooth. Because if we are not saying the plane is smooth, so it means we have friction. Okay. Because we have friction here, so there is some friction. It's okay. It means so we can let's mark the friction on the three-point diagram. Let's assume the friction is going because we are pushing up. Let's assume the friction is going down. It's okay. So this is the three-point diagram we need to go further. So we have four forces. Now, after drawing the three-point diagram, we do the calculation. So for the calculation, do we assume motion or we assume no motion? So because if there's motion, then summation f will not be 0. It's okay. So either we assume motion or we assume no motion. So let's go back to last page. I will come back. So remember our SOP means we assume we have no motion. We first assume we have no motion and then we do all the calculations. Okay? We first assume we have no motion. We assume we have no motion and then because there's no motion, we have summation f equal to 0. From here, we can assume summation f equal to 0 and then determine f and r. It's okay. So we first assume we have no motion. And then we determine the values of f and r, the reaction force. It's okay. Here we assume that we have no motion and then we determine f and n, which is r. And in the text, this is from the book, and they use summation fx in this direction and summation fy is in this direction. It's up to you, okay? And as long as you have two equations, it is fine. You can use this one as x and this one as y. It's also okay. Now, for the second step, we calculate the maximum friction force, which is mu s times r. This is the next step of our SOP. So maximum friction force is equal to mu s times n in this problem. which is equal to 0.25 times 240 Newton equals to 60 Newtons. It's okay. Now, in the next step, we compare this one and this one. Remember one thing. For f, for the value of f, we get it is minus. So in physics, actually, it is this force is 18 Newton going. Oh, sorry. 18 Newton going upwards. Just to remind you. Okay, and this one is going upwards. And the maximum friction force, because the value of mu s is 0.25, so maximum friction force is 0.25 times 240 is 60 Newton. So first of all, we write the maximum. Sorry. Friction force friction is smaller than force. Friction required for equilibrium. Right? Because the friction force, if we assume no motion, then F is equal to 80 Newton, but the maximum friction force is only 60 Newton. It means that we don't have enough friction to hold the block in place. So the block will have motion. But now, it means if the maximum friction force is not enough to hold it in place, so the block will slide. But does it slide up or slide downwards? The problem is, will it slide up or will it slide down? Because to hold this block in place, we need 18 Newton going up. But in physics, the maximum force going up is 60 Newton. So we don't have enough upward force. So actually, the block will slide downwards because we don't have a upward force. We don't have enough upward force. We only have 60 Newton of upward force, but we need 80 to hold it in place. So we need 80 newtons to hold it in place, but we can only give 60 newtons. So the block will slide downwards. Okay. This is the key points in this example. We need to get this right. The direction of F should is going upwards, so then you will make this, you will get this right. Now, so it means there is motion. There is motion, then the actual friction force is equal to what? The actual friction force will be equal to mu k times r, which is 0.2 times 240 newtons. And F is equal to 48 newtons times, angle is 47 degrees. And this one is sine 0.6. And this is the how we work out a problem with friction. So let's have a take your time to write them down, and afterwards that I will go back to the last page and go through it once more. Now, in the here we first, sorry, can I make it a bit smaller? Here we first assume we have no motion. We begin with no motion, okay? We begin with no motion, and then if we guess the friction force required to hold it in place. But and then we calculate the maximum friction force available. So if the maximum friction force is, because in this case is not enough to hold it in place, so it will have motion, and then we need to recalculate the friction force, because if we have motion, the friction is related to mu k, not mu s. Okay. If we have motion, it is related to mu k, but not mu s. Is that okay? Let me go back quickly to the last page. I'll come back. So for the last page, and so this exactly what we do, what we did in the SOP. That we assume we have no motion, and determine the friction force and the reaction force. And then second step, we calculate mu s times r, which is the maximum friction. In the problem, we get this one. F is larger than mu s r, and then we determine there's motion, and we determine F is, we calculate F is equal to mu k times r. This is what we are doing in this sample problem 8.1. It's okay. This is what we are doing here. Now, if if you're fine with this part, and then you can go to the next. Then you can have a look at the next page. So we go to the next page, and in this graph, in our graph here, and in our graph here, you can read it's on page 61, right? You don't need to draw this. You don't need to draw this. But I'm just okay. For this graph, what's the x-axis? P, the external force pushing it. And what's the y-axis? F, friction. Okay? Remember that, of course, all of us can draw the shape, but remember what the x-axis and y-axis, what are they? Okay? So, here we have two lines, and this is mu s times r, and this is mu k times r, right? And we use these two quite often. So, and for both of them, or in the book, in the book, it would write mu s times n or mu k times n. In this, on the figure below. Now, we can see that these two values of f are related to n, right? And the relationship between n and f is like n is perpendicular to the surface, and f is along the surface. That these two goes to 90 degrees, right? For a block, right? For a block, n is always going this way, going perpendicular to the surface, and f is going along the surface. Of course, we assume p is this way, and the relationship f is always along the surface, and n is perpendicular to the surface. So, and we know this one is, we know this is, the first thing is this one. The second thing is we always have some relationship between f and n. So, we do one thing, and we determine this, because the summation of these two forces is this one, right? This one is R in the on the figure here. It's okay. N is always perpendicular to the surface, and F is along the surface, and the summation of two forces is R, right? So for this angle, we can mark it phi. We mark this angle phi. So you may ask why I'm doing this. For this, let's take a look at these two cases. For example, for motion impending, in motion impending, we have F is equal to mu s times n, right? So So we have, how should I write it? F divided by N is equal to tangent phi is equal to mu S, right? In this case. Is that okay? Because we know N is always perpendicular to the plane and F is along the plane. So we have 90 degrees here. And for this angle phi, that tangent phi is equal to mu S because this one is equal to mu S times mu S times N is equal to P, right? I will say, let's assume, let's make the problem simple, and P is P has only one direction, and we don't consider this. I'm sorry. It's okay. Or Px. It's okay. So we know when it is motion impending that the angle of the resultant force has an angle phi here with the line of action of N. So this one we will mark it as phi S. And if it is in motion, if it is in motion, and mu F is equal to mu K times N. So F divided by N is equal to mu K, and this is, we will say, this is tangent phi K. And this angle is phi K. So you may ask me, and so this angle phi is because we can always write an angle phi here between F and N. F and N, we can always write an angle phi here. This is called angle of friction in this textbook. And you may ask me what's the use of this. Let's take a look of the figure below. I will talk about one of them in the. I will talk about one of them here, and I will talk about the other two on Thursday. Let's go to the second. Let's go to the second. This is one block on an inclined plane. So a block on an inclined plane, then it can move up and down. Assume. So we have suppose we have W here, and in this case we don't need to, and suppose we don't have pushing up or pushing down, but we are asking whether it can hold in place for this block. Oh, sorry, I should go to the first figure. Sorry, let me go to the first figure. Now, for this and the incline angle is theta. For the three-point diagram of the block, what should we draw? We have W. What else do we have? Because it is in touch with the plane, so the plane has reaction force to the force, the reaction. It has a reaction on the here, right? But does fx equal to 0 in this case? Seems not. It will slide downwards, right? If it is smooth. If it is smooth, then it will slide downwards. But now we have friction. The friction stop it slide downwards. Then it has a friction going up. Right? Or should I draw it like this? Wait a minute. Let me draw it like this. So it's the three-point diagram of this block. Now, we have, let me draw the summation of let me draw the force diagram over a point. We have W here, and then we have R here, and we have F here. So, if there is no motion, it is in equilibrium. Let's not look at W, and we look at R and F. If it is in equilibrium, it means R plus F is equal to R plus F is equal to minus W, right? And here we know the incline of the plane is theta. And we know that this is also equal to theta. Does the logic sound okay? Because we know the incline of the plane is theta, so this is theta. Because this one is 90 degrees, this one is also 90 degrees, so this one is also theta. And this one is 90 degrees, and this one is also 90 degrees. It's okay. this for a block incline that we have this one. And on first day we will compare this one and this one. Because what is this theta? This in this figure, theta is the angle of between R and the angle between R and the summation force between R and F. What's phi here? The angle between the reaction force and the reaction force and the friction force. The reaction force and the resultant. These two are the same thing. These two are the same thing, and we will compare them on first day.